Hello everyone, welcome to my channel. In this video we are going to see about the generator protection. Normally the generator which we are placed in our substation or even a thermal power plant or a hydropower plant, like a power plant kind of thing, there have a lot of protection for the generators. In our next video we will see about the common protections. Now we are going to see the general protections of the generators, which means the commonly taken protections in our generator system. The generator protection, which consists of a prime movers, excitation systems, and the voltage regulators, cooling systems. So this all comprises parts of your generator. And the common fault are in stator, phase to earth fault, then phase to phase fault, then interturns, which means uh, the main winding. In case of a large hydro power plant, the the winding may be uh, splitted into a two, which means one winding will be paralyzed into a two windings in this case. So for this case, the two windings should be protected in a such a way the interturns fault can happen and protection need to be done. Next is the rotor fault. Rotor fault may be a rotor temperature indication as a winding temperature. Likewise, in the sense rotor temperature windings indication will be shown. Then the rotor earth fault relays, in which the rotor earth fault can happen and relays protections need to be done. Then abnormal running conditions like overloading, overspeeding, unbalanced loading, over voltage, failure of prime movers, then loss of excitation, then cooling system failure. These are all the common abnormalities in your generator. In here, the loss of excitation in the sense field failure, which means opening of a field coil or a short circuit or due to some of the fault in the exciter system, the field failure may happen. So these are all the common faults in your generator, and to overcome this fault we are going to see the protections of the generators, what are all the basic protections taken in your generator. So mesh price protection of alternator stator windings. Here the mesh price in the sense protection is also known as a biased or a percentage differential protection of your generator. In this consists of two types of connections, which means star connected connection and the delta connected alternator connections. The connections are varied by the CT connections, which means for a star connected alternator or generator, it consists of a star type connections of your CT combinations, while we are checking with the delta type connections. In here we have a delta type of connection in the CT also, which means it will reflect in the CT also. We need to do as a delta type of connections. Then the main thing is that the area to be protected is within our zone itself. So the star pointing and everything will be done within our zone itself. That's why I have mentioned as a CT earthing, neutral earthing point, CT2 and CT1 areas within the zone. Then the next thing is that the relay output coil, which means the operating coil and the restraining coil. First check with the star connected alternator, in which the operating coil is in parallel with the restraining coil, which means the midpoint of the restraining coil is connected with the operating coil, and the operating coil are connected with the your star pointing end of your CTs. So whenever the uh, restraining coil is above the operating coil level, in the sense set value means there is no fault current and it will be flowing as a normal thing, which means there is no fault current observed in the relays. When the operating coil is overcomes the restraining coil, in the sense automatically there is a fault sensed by this relay, and due to this sense it will initiate a trip to your circuit breaker and circuit breaker gets opened. So this is a common things in your star connected alternator, and the same thing, same principle, same kind of sensings, which means normal operation and fault conditions are happened in your delta type of connections also. So as I said, the restraining and the operating coil is placed in each phase, and the energy from the secondary connections of the CT, the the operating coil is energized from the restraining coil, and under a fault condition the differential current flows through the operating coil, which is responsible for the trip of the operation and opens the. Next is your restricted earth fault protection. So in here both the relay, which means the CT from CT1 on the neutral side and the CT2 which is feeding on the uh, load side, between the protected zone, which means the windings are protected. In here both the CTs are connected with the operating coil, and parallelly in the series with the uh, relays there is a one resistor will be connected. The resistor will restricts the over current to entering into the relays, and the relays can be protected. In the sense the resistor which is responsible for the measurement of the, which means allowing the current level which is under your set point of our tripping level. And next thing is that the when you see the neutral side there will be one earthing resistor. This earthing resistor also a main thing for carrying the protection. When the neutral is solidly grounded, then the generator gets completely protected against the earth fault. But when the neutral is grounded through a earth resistance, or even in a reactor you can see a NGR, which means a non-grounding resistor. So in the case we are using a non-grounding resistor as a earthing resistor in the name. The stator winding get protected against the earth fault. The percentage of winding protected depends on the value of the earthing resistors and the relay settings. So when earth fault occurs near the neutral point, the insufficient voltage across the fault drives the very low fault current, then pick up current of your relay coil. Hence the relay coil remains inoperative. If we kept relay settings in a low value, which means low current value, then the wrong operation may be happened due to the saturation of CTs or inaccurate burden on our both of the CTs. So practically 15% of your winding from a neutral point is kept unprotected. Remaining 85% of the protections are being carried out in the earth fault protection. So this is the restricted earth fault protection basics of your generator. So next is your balanced earth fault protection. In here we have three CTs, which means ROAB phase of your CT. Three phase CTs are parallel each other and connected to the neutral side, one neutral CT, and are taken to your relay coil. So in the sense we can easily have a idea that the relay will operate only for the internal faults, which means inside your protected zone. In here the protected zone is your generator, stator winding, or even as for a transformer also we can use this kind of connections and protections for your transformer winding and reactor. Under a normal also condition, the vector sum of your current of your neutral and the outgoing CTs which are placed on the load side, both should be in a equal or more or less below the set value. So in this time the relay will be in a inoperative condition. So whenever the fault is in outside your zone, in the sense it will be a external fault, not an internal fault. So in that time, the sum of your generator line current will equals your neutral current. So in that time also, the relays will be inoperative due to the relay coil current is very less than your set value. So if the fault is occurring inside your protected zone, in the sense, then the 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 current in will be there will be a difference in your current from your three phases and your neutral, and the relay coil gets pick up and the relay will trips. Then 100% earth fault protection. Here the stator of your generator is protected by a uh, coupling transformer, which has some of the measuring devices, and also uh, yes, a particular frequency signal will be injected into your transformer winding, and it will be checked continuously. When it senses some of the fault or abnormality, in that time the earth fault protection will be operated and a trip will be initiated. So a coupling transformer is connected between the earth and your earthing resistance. The primary of the coupling transformer is excited by a coded signal current source or anything. The coded signal current has a frequency of 12.5 Hz. So the current is continuously injected into your generator stator winding through a secondary of your coupling transformer. Then during the normal condition, the signal current injected into your stator flows through the stray capacitor of the generator, and when the earth fault occurs, the stray capacitor get bypassed. So this in the sense, the increase in your current is measured by the measuring device, which is placed between your primary of your device and your depending on this earth fault uh, relay or under voltage relay for neutral connections or other any other specific relays connections, this protection will be carried out. So from this type of protection, the stator winding will be fully protected, which means the re- remaining all, in which area the 15% we are not able to cover, in here we are taking the protection which means starting the protection from that 15% area which are not able to cover. So the coupling transformer which is uh, installed in after the earthing resistance path, in the sense it will covers the total protection of your generator. Nowadays this signal source of your frequency which we are injecting, that's also been changed or varied according to the modifications or according to their model or rating of generator which the customer is using. So this and all the common things of protections are carried out in our generators. Then in next video we will see about the stator protections and rotor protections, loss of excitations and everything. Hope you understand. I think so. Thanks for giving your knowledge. Share your knowledge and gain your knowledge. Thanks everyone. Nandri Vanakkam.